What you're looking at here is the latest frequency generator like circuit, but this one here has a twist to it. This one here has actually got a silicon control rectifier, which is only for DC, but the output is actually a measured 3.97 volt AC output, and between the outputs I've got a 1.0 euro 250 volt non-polarized capacitor. The frequency is adjustable from a low 31 to 38 hertz, which is alright if you want low frequency zapping. Now the catch to this thing is that flash LED won't respond until the circuit senses a resistance, like it be your body, like if you hold that there. As soon as the charge gets through your body, triggers the SCR gate, whatever, so I think it is, the flash LED will respond accordingly, and you can adjust it with the 25 ohm rheostat. That's the wire round rheostat. That's the one I use in the Bayjack capacitor experiment. Right, now on the output here, on the input here, between the 9 volt input and negative input, I've got a 1000 microfarad filler capacitor there. Right, now the capacitor between 1 and 2 of the pin 1 and 2 of the timer is also a 1000 microfarad capacitor. Right, now when you turn this thing on, the LED won't flash, but once it gets senses a resistance across your body, whether you put both outputs on your tongue or on your forehead or so far apart, once it senses the charge going through your body to the other electrode there, the LED will start flashing in response. Right? Now, it will look like it's flashing at the same rate pretty fast. It might look a bit slower at times, faster, but it's doing its job anyhow. Now, even if you got it turned up to a spot where the LED's not flashing, it's still pulsing, like the gate's still kept open or closed on the triac there. The silicon control rectifier. Right, now this is the schematic right here. If you look carefully, okay, 31 to 38 adjustable low frequency AC zapper. This is nearly the same setup as the most frequency pulsar circuits. Okay, I've got two 1000 euro capacitors, one between the positive and negative input, and one between pins 2 and 1. And you notice that I've tapped the positive of the capacitor, which runs to pin 2, and I run that down in and joins onto the 100 ohm, bottom of the 100 ohm resistor, which also goes back up there to the 470 ohm on the positive side and to the potentiometer there. So you can see how I got it. That little line here, that's just the back plate of the silicon control rectifier, and these are the outputs here. Right on each side of the 1.0 US electrolytic non-polarized capacitor. Right, and there's a 100 ohm resistor. I replace a 470 ohm with 100 ohm resistor, and it seems to work much better. If I put that back up to 470 ohm, or if I go to 150 ohms, the frequency output will drop. It will drop like to about 15 hertz or whatever that there. Pretty low hertz, but I want to keep it really about that anyhow. Okay, that's about it. Thank you for